So here I'm going to discuss about the given question which is asked in GATE 2020. And this question you can see here there is an elementary liquid phase reversible reaction in which reactant P is getting converted into product Q is carried in an ideal continuous STR tank reactor operated at a steady state. Okay, so the reaction rate of the rate of consumption of P is given as minus Rp, which is in mole per liter per minute, is given by Rp is equals to Cp minus 0.5 Cq, where Cq is the concentration of product Q and Cp is the concentration of product P. Now, here they are saying the feed contains only the reactant P at a concentration of 1 mole per liter, and the conversion of P at exit of CSTR is 75% of the equilibrium conversion. Okay, assume that there is no volume change. I mean, here you can see there is a liquid phase reaction, so volume change won't be there. So they assume that there is no volume change associated with the reaction, and the temperature of the reaction mixture is constant throughout the reaction. The space time of the CSTR is, so here you can analyze the question. They are asking about the continuous space time of the continuous STR tank reactor for the reversible reaction. Okay, so let me explain some basic things about the continuous STR tank reactor. Then I will discuss some basics concept about the reversible reaction, how we calculate the equilibrium constant, and how equilibrium constant is related to the equilibrium conversion. Then after we will proceed. Okay, so if we see if we see the reversible reaction. Okay, so here they are talking about if reactant P is getting converted into product. Okay, so reactant P product में convert हो रहा है, और the reaction is happening in a steady state in a continuous STR tank reactor. Okay, so what is the the basic mechanism of the continuous state STR tank reactor? Okay, so if reactant P is engine here, and the concentration is given as 1 mole per liter. Okay, so I am not writing here concentration. So if you see, if you define the space time of a continuous STR tank reactor, so tau that will be equals to Cp naught minus Cp upon minus of Rp. Okay, so this comes from the material balance. Okay, just you have to understand how it is happening. So this is the space time of the continuous STR tank reactor. Okay, so if you see here, now here what is given, Cp naught is given here. Okay, in the question Cp naught is given here is 1 mole per liter. Now minus of Rp, that is also given, and that is written in terms of Cp minus 0.5 Cq. This is very important parameter, that is Rp, that rate of disappearance of P in the reversible reaction. P is getting converted into Q. Okay, now understand one thing. What is happening here? I am letting you to understand some basic concept about the reversible reaction. Then we'll come forward to the continuous STR tank reactor. So if the reaction P is getting converted into Q, then what happens at equilibrium? What will happen? Rate of reaction will be equals to 0 at equilibrium. So we can see minus of Rp, that will be equals to 0. It has to be 0 at equilibrium. Okay, now try to understand one thing here. At equilibrium, if rate of reaction is equals to 0, then what will happen? So here if Cp is the equilibrium concentration of reactant P minus 0.5 Cq this is the equilibrium concentration of reactant Q, that will be equals to 0. So here you can write Cp naught into 1 minus Xe. I am assuming it Xe is the equilibrium converter. So that will be equals to 0.5 Cq naught plus Cp naught Xe. Okay. Now I am assuming here, if you can generalize these things, but if you don't want to generalize, just I am writing it here. So here, if you see in the question, they have given the initial concentration of CQ is 0, means only reactant is entering into the reactor. Okay, so CQ naught will be equals to 0. So here you can write CP naught into 1 minus XE, that is equals to 0.5 CP naught XE. So CP naught will get cancelled out. So 1 minus XE, that is equals to 0.5 XE. Okay. So here we can write XE upon 1 minus XE, that is equals to 1 upon 0.5. So that is equals to 2. Okay. So you have derived these things. Now, if this is if you can generalize these things in this way, so I am just generalizing it here. So here you can write XE upon 1 minus XE, that is equals to K equilibrium upon 1 plus, that is equals to K equilibrium, and that is equals to K1 upon K2, and you can write it as rate of forward reaction upon rate of backward reaction. Okay, so now here you can write Xe upon 1 minus Xe is equals to K equilibrium, so that is equals to 2. So here if you want to calculate Xe, so X will be equals to 2 upon 1 plus 2. This is just a simple mathematics that you can do. So here you can have calculated Xe, that is the equilibrium conversion. Now in the question they are asking about the conversion of reactant should be Xa, and it should be 0.75 of Xe, that is mentioned in the question. Okay, so you can calculate Xa is equals to 0.75. We can write 3 by 4 multiplied with 2 by 3. So here it will get cancelled out, and now here you can see the conversion is will be equals to 50%. I mean, you have to calculate the space time of the continuous state tank reactor when the reactant is getting 50% converted into the product. Okay, now here we have got the uh, our reactant is P, that's why you can denote it as a with by P. Okay, so it will be very easy. So there is no any chance of confusion here. Okay, so XP will be equals to 50%. Now coming to the question, we have got the conversion. Okay, now we have to calculate the space time of continuous state tank reactor, and that we have written Cp naught minus Cp upon minus of Rp, and we know this is a reversible reaction. Okay, so we can write tau is equals to Cp naught into 1 minus Xp. My here you can write Cp naught minus Cp naught into 1 minus Xp. I mean after conversion of 50% upon the Xp, the rate of reaction that was given as Cp minus 0.5 Cq. So if you want to proceed further, you can write it Cp naught minus Cp naught plus Cp naught Xp upon here again you can write Cp naught into 1 minus Xp minus 0.5 Cq naught plus Cp naught Xp. Okay, so here you can write it in this way. Now again I am referring it finally. here you can write that is space time tau, that is equals to, here it will get cancelled out. CP naught will get cancelled out. So here you can write CP naught XP upon CP naught. And again one thing is that here is CQ naught and it will be also 0. What? Why? Because in the question it has been given that only reactant is entering into the reactor. So CQ naught initial concentration of product will be 0. So it will be equals to CP naught minus CP naught XP and minus 0.5 CP naught XP. Okay, I think it's clear to all of you now up to here. Now, if you see in the numerator and denominator, it's totally a mathematics. CP naught term is there in the numerator and denominator, so I am just cancelling it out. So XP upon 1 minus 1.5 XP. So we have got the value of space time tau. So here you can substitute this value, that is equals to 1 upon 2, XP is equals to 1 upon 2 minus 1 minus 1.5 upon 2. So here you can write 1 upon 2 upon minus 1 minus 0.1.5 by 2 is equals to 0.75. So here you can write it as 1 upon 2 upon 1 upon 4. So that is equals to 2. So we have got our answer, that is equals to tau is equals to 2 seconds. Hope you all have got the desired answer that we wanted to proceed. So first what I have discussed about the continuous state tank reactor, where what will happen, the reactant here P is entering into the reactor, and what will happen, we know that the material balance of the continuous state tank reactor, and from here we know tau is equals to Cp naught minus Cb upon rate of reaction. Okay, so here from there and this is also a reversible reaction. So in case of reversible reaction, we have to calculate the maximum achievable concentration, and that maximum achievable concentration is used to be, that is the equilibrium concentration. Okay, this is called as the maximum achievable concentration also. So in question, if it is written calculate the maximum achievable concentration, so it will be equal to the equilibrium concentration. Okay, hope you all have got the answer. Okay.